So for this last video, we're going to be talking about the segment addition postulate. But before we get into that, I do want to clarify one thing. So when we say that 3 points are collinear, just remember that just means they're on the same line. You can say that one point is between the other two. So we can see that example down here. So point B is between A and C, and we see that because they're all on the same line. They're collinear. Where in this one, point E is not between points D and F because it is not on the same line. So getting into the segment addition postulate, if B is between A and C, then that means that AB plus BC is equal to AC. And then we can also do the flip of that. So if AB plus BC is equal to AC, then B is between A and C. So all the segment addition postulate is telling us is that if we have this segment here, AC, I can take these smaller segments in here, so this AB and BC, and when I add them together, I get the whole segment. So it's kind of like you can think of this as fraction parts. So if I have, let's say, the box, and it is divided into 4 coordinates here. I have this whole box, but if I were to add all 4 of these parts to it together, it's going to equal the whole entire box. So that would be 1/4 plus 1/4 plus 1/4 plus 1/4. That's equal to 4/4, which is 1. So that's all this segment addition postulate is saying. We can, all the broken up pieces of a whole line segment are going to add up to equal the whole. The parts are going to equal the whole, or the addition of the parts equals the whole. So let's try some of these problems. So this first one says to find xz. So xz, that's going to be this entire thing. Well, I know from my segment addition postulate up here that the whole xz is going to equal to the parts that make up it. And that's because that y is between x and z. So I can say xz is equal to, well, it's equal to xy plus yz. Well, xy here is, I'm told that's equal to 14, and yz is equal to 27. And so when I add all of those up, I get 41. So here xz is equal to 41. Okay, now let's try the next one. So this time I want to find CD. I don't know this little part here. So I'm going to go ahead and start this off the same. I know that the whole here, BD, is going to equal to the part. So it's going to equal to BC plus CD. And now I'm just going to plug in the information that I know. Well, I know BD, based on this picture, is equal to 36. I know BC is equal to 19. But I don't know CD, so I'm going to leave that as CD. And now we just have an equation that we want to solve. I want to get CD by itself, so I'm going to subtract 19 from both sides. And so when I do that, 36 minus 19, I get that CD is equal to 17. Okay, now let's try one that's a little bit harder. So here I'm told that M is between N and O, so that means I can use my segment addition postulate, and I want to find NO, so I'm looking for this entire thing. So I'm going to start this off the same. I know that the whole NO is equal to the 2 parts, so it's going to equal to NM plus MO. And now I'm going to plug in everything that I know from this picture. So I know that NO is just 5x plus 2. NM, I'm told, is 17. And then MO is 3x minus 5. So MO, that matches here. NM matches my 17. And then the whole thing matches there. So the two parts equal the whole. And now I'm going to use my algebra skills to solve this for x. So I'm going to first combine my like terms on this side. So I have a 17 minus 5. Well, 17 minus 5 is just 12. I have an x on both sides of the equation, so I need to get them all on one side. I'm going to move my smaller one, so I'm going to subtract 3x from both sides. So I get 2x plus 2 is equal to 12. Then I'm going to subtract 2 from both sides. 12 minus 2 is 10. Divide by 2. And I get x equals 5. Now I'm going to look back at the question. What is the question asking us? The question is asking us to find NO, not just x. So to find NO, well, I know NO is equal to 5x plus 2. I know what x is equal to, so I'm going to plug in my 5 for x. So instead of 5x, I'm going to have 5 times 5 plus 2. So all I did was plug in x equals 5 into my NO right here. Well, 5 times 5, I get 25. And then 25 plus 2, I get 27. So NO is equal to 27. Okay, go ahead and pause the video and try doing that last one on your own. Okay, so for this last one, you should have gotten that DE equals 11. So I again used my segment addition postulate. I know that DE plus EF is going to equal to this whole thing. And then I plugged in all the information I knew, so I got this. And when I solved that, I got x equals 4. At the very end, it wanted you to solve for DE. So I plugged in 4 in for x, and I got 11. Okay, that's it for today. If you want extra practice, there is some available at the end of this page, or you can look at some extra examples. If not, you can move on to the assignment, which is a drag and drop activity. Have a great rest of your day.